Hello, everyone. In this video and the next one, we will learn how to factor polynomials. And here, the first example, we will look at the greatest common factors. And the second one, we will factor trinomials of the form x squared plus bx plus c. And in the third one, we will factor trinomials of the form a times x squared plus bx plus c. So let's take a look at these problems. The greatest common factors. Problem 1. Let's factor the following two polynomials. A, you have 36 x to the 6 plus 30x to the 4th minus 12x squared. And here, we first look at the numerical part, 36, 30, and then 12. Here, the greatest common factor is 6. You have 6 times 6, that's 36, and 30, 6 times 5. Then you have 12, 6 times 2. Okay, this is the largest number that is a factor of all these three. So we first factor 6 out, factor this out. That's the numerical part. Then for the variable part, you have x to 6, x to the 4th, and x squared. All of them have the same base x. And you pick the smallest power, that is x squared. So we factor this x squared out. So factor that out, that means here, what's left? So we need to divide each term by 6x squared. The first one divide by 6x squared. Yep, 6x squared plus 30 x to the 4th divided by 6x squared minus 12 x squared divided by 6x squared. So, most of the time people will skip this step, and let's do this. 36 divided by 6, that is 6. And x to 6 divided by x squared. So you have x to raised to 6 minus 2, which is 4, plus 30 divided by 6, that's 5. And x to the 4th divided by x squared, that is x squared. 4 minus 2, right? The power. Then you have 2. X squared divided by x squared, that's 1, right? 2 minus 2 is 0. So x to the 0th power, that is 1. And of course, then we need to check if we can factor the inside. In the last example in this video, you will see this is not factorable. So here we just factor out the greatest common factor. So we got 6x squared times parentheses 6x to the 4th plus 5x squared minus 2. And this is the first one. So we find the greatest common factor and factor that out. And let's take a look at the second one. 24x to the 3rd y squared plus 15x squared y. And here the numeric part, 24 and the 15. 3 is the greatest common factor. Then there are two variables here. And the first one, you have x to the 3rd x squared. So we pick the smaller power, x squared out. And then y squared y. We factor this y out. And then you divide 24 divided by 3, that's 8. And x to the third divided by x squared, that is x to the first, which is just x. And a y squared divided by y, you have y. The second one you divide, so you have just 5. Okay, so this is how we factor the greatest common factor. And the second type, we will have problems here. Second one, you will see trinomials of the following form. You have x squared plus bx plus c. And here, if we can factor, it should be something looks like this. X plus, let's say, a times x plus b, right? Because by FOIL, and you will see x times x, and you will see x squared. And x times b, we will have bx. Then a times x, you will see ax. And a times b, you will see ab, right? So x squared, we already have x squared. And then these two x terms, you have ax plus bx. So that is just a plus b times x. You factor x out, right? And then the last term is ab. So that means here, and we want to find two numbers, lowercase a and b, such that a plus b equals the uppercase b, right? And a times b, which is c, right? So anyway, we want to find two numbers, the sum, two numbers such that the sum is b. And the product is c, right? And usually it's easier to factor this constant c. So that's why we will try all the factors, all the factorization of c, and then find which sum will give us b. So let's take a look at our first problem. Let's say here we have x squared minus 6x plus 8. So we want to try to find two numbers whose product is c, which is 8, and the sum is -6, -6. And since here the product of a, b is 8, so a and b are both positive or both negative. So we factor this 8 is either 1 times 8 or 8 times 1. And it doesn't make any difference. All -1 times -8, or you might have 2 times 4, and or -2 times -4. And if we want to get two numbers, the sum is -6. So obviously this one works, right? -2 and -4 works. This is the right one, right? This is the right one because the sum is -6, because you have -6 equals -2 plus -4. So that means the original trinomial can be factored as x minus 2 times x minus 4. And you can check this is the right one. This is the right one. Okay. This is the right one. Okay. Let's take a look at another one. Another very similar one. So here we got x squared minus 5x minus 24. So remember, we first factor this -24. -24, you have, so this is the product of two numbers. So one must be positive, one must be negative, because we have -24, right? So you might have 1, -24, or -1, +24, right? Or 2 times 12, -12, and -2 times +12. And you can check, we try to find the sum of the two numbers as -5, or 3 times -8, or -3 times +8. And you can stop here, 4, 6, 6, 4, because we already know the sum of these two guys is -5. So when you factor this -24, and you keep checking, oh, do we get -5? And yes. And many times, you skip the 1 and 24. Anyway, there's no way to get 5, right? Either 5 or -5 or +5, right? No way. So so you pick the most probable one, right? Okay. So here we have -5 is the sum of 3 plus -8. And this is the right one. So that means our polynomial can be factored as x plus 3 and x minus 8. And you can check this is the right one. This is the right one, okay? Okay. Here we have in these two examples, we have the leading term 1 times x squared. That's 1x squared, right? And let's change a little bit. Let's say here we have a times x squared plus b times x plus c. So this is different. Here we have this a here. So in this one, for this one, and we can factor this ax, let's say ax plus b times cx plus d. And it is more complicated, right? We need not only factor this c, but we need to also factor this a, big A. It is more complicated. But if you multiply out, you will see FOIL out in the combined like terms, and you will see we have a times c squared plus x. Then the constant term is b times d. B times d. Okay, so we have AD plus BC. AD plus BC, right? Okay, if you check the original one, so actually what is our A times C? Let's check. Why you might ask me like why we need to look at A times C, and we will see that A times C. So you have AC times BD, right? That is ABCD, right? And then you check the middle term. You have B equals AD plus BC. Okay, let me rewrite this A times, the big A times C. Okay, you will see what's going on here. So actually it is AD times BC, right? So from these two equations, we try to find two numbers. One is AD, the other one is BC. Right? So that means here we want to find two numbers. One is AD, the other one is BC. Right? So two numbers. One is AD. This is one number, okay. And the other one is BC. And we want to the sum to be B, the big B. So that is the sum of these two numbers. And the product is A times C. Okay. It is, it is very similar to the second, the last time you have x squared plus big bx plus big C, right? We try to find two numbers with product, the big C, and the sum of some B. Okay, so let's take a look at how to, you don't need to remember all these, but you need to know how to factor. Let's say the first problem, 3x squared plus 7x plus 2, where this A is 3 and the B is 7 and the big C is 2, right? So you multiply A and C. AC equals 3 times 2, which is 6. And we want to factor this 6, okay? And then our B is 7. And we want this to be the sum of these two numbers, okay? So we first factor this 6. 6 is positive, right? So either 1 times 6 or -1 times -6 or 2 times 3 or -2 times -3, right? They are the whole numbers with the product 6, right? Okay, here we need to find the sum of each pair. And since this is positive 7, so actually this is the right one. 7 equals 1 plus 6, 1 plus 6. But of course, how to factor? And here we need to follow this procedure. Like, let's say the original one, 3x squared plus 7x plus 2. I'm going to rewrite this one and split the middle term, 7x, as 1x plus 6x, or 6x plus 1x. Okay, they're the same. Let's say 1 plus 6, so 1x plus 6x. And then we have plus 2, right? And we group them. The first pair, the second pair. And for each pair, we factor the greatest common factor out. So the first pair, we can factor x out. Then you have divide 3x squared by x. So you have 3 times x to the first, which is just 3x. And then here plus 1. Okay. Very similar for the second term, we can factor 2 out, then 3x plus 1. Look at these two terms. And what is common to these two terms? This is a common factor of these two terms. So let's factor this out. So you have 3x plus 1. Then times, so we already factored this 3x plus 1 out. So in the first term, you have x left. And in the second one, and you have 2 left. So this is 3x plus 1 times x plus 2. And you can check this is right. This is the right one. Okay. Questions? Let's go to the next one. I will show you one more. And this one is very similar to the one we just did. Let's say we got 6x squared minus 7x minus 20. And then remember here, a times c is 6 times negative 20. So negative 120. And we want factor this as the product of two numbers. Okay. Then b is negative 7, the negative 7x. And this is the sum of these two numbers. Since here we first factor this negative 120. Negative 120. So there are a lot of factorizations, right? Either 1 times negative 120. Obviously, this doesn't work. We cannot get 7 out of these two, right? Or negative 1 times positive 120. And we keep going. 2 times negative 60. And 2 and 60 are either plus or minus. You cannot get 7. So we skip this one. We can skip this one, right? And 3 times 40, negative 40, still doesn't work, right? You add them, then you have negative 37. The other one, you have negative 37, right? Then 4 times negative 30, still does not work. I keep going until you have, let's say, the next one, 524. No, 620. It's about 14, right? 14 positive 14 or negative 14. It still doesn't work. 6, how about 8? times negative 15. This one works, right? Obviously, this one works. So we skip all of this. So at the very beginning, you might just pick like bigger numbers than 1 and 2 and 3 and 4. You will not get 7 or negative 7, right? So this one works. For negative 7 equals 8 plus negative 15. So let's go ahead, rewrite the original trinomial. And this one, of course, it doesn't matter 8 plus negative 15 or negative 15 plus 8. Let's try the second one. 6x squared plus negative 15x, then plus 8x minus 20. Let's switch the order of this pair, see if this one works. Okay, for the first pair, we can factor a 6 and a negative 15. We can factor 3 out. So you have 2x squared divide 2, no. This is the numeric part is 3, but then the variable part is x. So we got 2x, then minus 15, negative 15 divided by 3, negative 5. 2x minus 5, okay? And the second one, we factor 8x and a negative 20. So we can factor 4 out. 4 times negative 2x, 8x divided by 4, that's 2x, right? 20 divided by 4, that's 5. See, here we have a common factor, 2x minus 5. We can factor this common factor out, 2x minus 5. And then the first one, you have 3x left. And the second one, you have 4 left. And you can check this is the right one. This is the right factorization. Okay, thank you.